Hi again, guys. This is Mr. Squire, and now that you've had a good bit of practice with addition, let's talk about multiplication this time. Now, it hasn't really changed very much. We're still going to use the same idea. Except we're going to be multiplying. So if we multiply, well, first of all, let's take a look at our mod here. Our mod here is 3. So we are going to be looking at 3's. So 0 times 0 is still 0. And remember that the only numbers we can use are 0, 1, and 2. But 0 times 0 is okay, because that gives us 0. 0 times 1, well, that's also 0. 0 times 2, that's also 0. So this one is going to be zeros all the way across. And that's, going to be the case in any mod or stuff like that. Also, it's going to be the case going down, because 0 times all that stuff. But let's start doing the ones. And we're in mod 3. So we do 1 times 1. That's going to give us 1. 1 times 2. Well, that's going to give us 2. 1 times 3, that gives us 3, but we can't use 3, so we start going over. There it is, 0. 1 times 4 is 4, so that's going to be 1. So the ones look actually like they're going to be pretty simple too. Going to be kind of just like addition. So 2, 3, 0, 1, 2, whoops, sorry, that was really bad. Because we can't use 3. So that just means that we have to, can't find my eraser here, but this is going to be a 0. That's a 1. That's a 2. That's a 0. 1, 2, and 0. Now let's kind of see what happens with our 2's. Well, 2 times 1, that's 2. That's acceptable. 2 times 2, that's going to give us 4. 4 divided by 3, that's going to give us 1 with a remainder of 1. So here we go. 2 times 2 times 3, well, that's 6. 6 divided by 3, that's going to be 2 with a remainder of 0. So here we have a 0. 2 times 4 is 8. 8 divided by 3, that's 2 with a remainder of 2. Now it kind of looks like it's counting backwards. 2, 1, 0. 2, 1, 0. Let's just double check. 2 times 5 is 10. 10 divided by 3. That's going to give us 3 with a remainder of 1. So it looks like that pattern is going to hold. 2, 1, 0. 2, 1, 0. Let's skip down here to maybe looking at some of the 5's. Well, 5 times 1 is 5, but we can't use 5. That's going to have to be a 2, because we have a remainder of 2 when we divide 5 by 3. 5 times 2 is 10, and we already said that 10 was going to be a 1. 5 times 3 is 15. Well, 15 divided by 3 is 5 with a remainder 0. Now I wonder if this pattern is going to hold. 5 times 4 is 20. 20 divided by 3 is going to be 6 with a remainder of 2. So it looks like this pattern's holding. Very, very interesting. Now, when we get up into these these big numbers, I hope you remember our times tables. 12 times 12 is 144. 144 divided by 3. Well, here we can use our divisibility rules for 3. Is 144 divisible by 3? Well, 1 plus 4 plus 4, that's 9. So yeah, it is divisible by 3, which remains that we're going to have a remainder of 0. That's the definition of being divisible. So this is going to be a 0 down here. What about this 12 times 11? Well, that's going to be 132. That's a 3 here. Well, is 132 divisible by 3? Well, 1 plus 3 plus 2 equals 6. So, yeah, I guess it is. So, 12 times 11 is going to be 0 in mod 3. 12 times 10? Interesting. All these 12s here, since 12 is divisible by 3, then everything we multiply it by is going to be divisible by 3. This is going to be all zeros again. And that's going to be the case whenever we have a multiple of 3. So that's going to be the case when we have 9. 9 times anything is still going to be divisible by 3. So that's all zeros. And if you notice in the 12 column, it's starting to look like that's all zeros too. Same thing with the 9 column, all zeros. So it looks like maybe we get all zeros when we have multiples of the modulus. Well, that's kind of crazy. Let's take a look at mod 8, just because, we're crazy. Well, we kind of know what's going on with this, with the 0 lines. That's going to be 0 all the way across. It's also going to be 0 all the way down. And then we think anytime we have a multiple of 8, we're going to have zeros all the way across. The only multiple of 8 we have here is just 8. So these are all zeros. But let's take a look at some of these others. 3 times, let's take 3 times 5. 3 times 5 is 15. 15 divided by 8, that's going to give us 1 with a remainder of 7. So 3 times 5 is going to be 7 in mod 8. Let's do 4, maybe try 4 times 4. 4 times 4 is 16. 16 divided by 8. That's going to be 2 with a remainder of 0. That seems unusual. Well, 4, let's go back to here. 4 times 1 is 4. We can use that. 4 times 2 is 8, but we can't use 8, so we got to go 0. 4 times 3 is 12. Well, that's going to be a 4 again. Interesting pattern, wouldn't you say? So the idea here is basically multiply and then convert to mod. Now, I suppose we could take Paul's suggestion that he gave us in the very beginning and convert all our numbers to mod 8 first. 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4. And the same thing all the way down. 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4. So let's take a look at, let's take a look at 12 times 12. So we know 12 times 12 is 144. And I'm hoping that that's divisible by 8. Or not. I don't, well, we'll find out. Let's see. 8 goes into 14 one time, which leaves a 2. And 8 goes into 24 3 times. That's 13 with a remainder of 0. So this 12 times 12 is 0 in mod 8. But now that we've converted 12 to 4 mod 8, let's see what 4 mod 8 times 4 mod 8 is. Well, 4 times 4 is 16. 16 divided by 8 is 2 with a remainder of 0. So it looks like it came out the same. So I think we're in pretty good luck. So we can look at either method, multiply then convert, or convert then multiply, and then we can fill out our multiplication tables. So I'm going to leave that for you. Again, 4 multiplication tables, mod 3, mod 8, mod 12, and mod 16. Thanks, guys.